Today we are going to dive into a very interesting topic of how to convert binary into decimals into hexadecimals and vice versa. My name is Dr. William Sobintre and I'm going to be your class teacher today. Our objective today is to understand the binary convention. Hello class, today we are diving into the exciting world of number systems. An essential topic in computer science. By the end of this lesson, you will learn how to convert a decimal number to an 8-bit binary number. 2. We have to convert the 8-bit binary number to decimals. 3. We have to convert an 8-bit binary number into hexadecimals. And 4. How to add two 8-bit two complement binary numbers. So I'm excited. Let's get started. This class is going to take about 15 minutes and I've divided this into introduction is 2 minutes. So let's do a quick recap. Binary numbers are used the binary numbers use base 2. Base 2 actually are only two states of numbers which are 0 and 1. This 0 and 1 is just like we want to put on a switch that's light a bulb. The 0 is off state and the 1 is on state. So we have two states. Normally we have been doing decimal numbers. Decimal numbers are in base 10 and they are read from 0 to 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hexadecimals are also numbers which are in base 16. When we say in base 16, when we need a binary number which is too big, we convert them into hexadecimals. And in that, we have 16 bits or 16 digits. The 16 digits actually start from 0 to 9 and A to F. So 0 to 9 is 10, A to F is 5, 6, making it 16. Why do you need to know how to use binary numbers? Binary conventions are important in computer science in data representation memory. If you're a network administrator, you have to know how to use binary numbers to write your uh, to build your network subnets. And as a programmer, you have to understand the binary numbers so that you can be able to know how your data is manipulated. So the first thing we have to do is to convert a decimal numbers to binary. So let's begin converting the decimal numbers to a binary. 25, 25 is a binary number, so we will use 25 as our example. To convert, we divide the number by 2 repeatedly and note the remainder. We have to watch closely. So we have 25 divided by 2. If you divide 25 by 2, the quotient will be 12 and remainder 1. We note the number 1 down. So now we divide the two quotient 12 by 2, we get 16. We get 6 and there's no remainder 0. We note it down. Now we use the quotient which is 6. We divide by 2 and we have 3 and there's no remainder. 3 is divided by 2, we have 1 and remainder 1. 1 divided by 2 is 0 and remainder 1. So we're going to use the remainder to represent our binary numbers. So we are going to write the numbers from the bottom to top. So we have 1 1 0 0 1. That gives us 1 1, 0, 0, and 1. Since we are in binary numbers, we have other binary 2 bits, 4 bits, 8 bits, and 16 bits. Most binary numbers adopt 8 bits. So the 8-bit binary number, we have to pad it with 000 to make it 8. So 1, 2, 3, 4, 5. We add two zeros, and so in base 8 or 8 bits, we have 000110001. Any question? Let's continue. The next is to convert a binary to decimal numbers. We are going to use this method. We are going to use positive values to do this. We're going to multiply, since this is bit 2, we are going to multiply each bits we have by 2 and raise that to its power according to its position. So from the right to the left, from the right we have 0. So from the right, which is 0, we are going to look at it that this. So example, let's convert 000110001 to decimals. This is our 25, which we converted. So the 3 zeros here are going to be 0. So let's forget about 3 zeros and start with this 11001. We go to the right end. 1 is raised to the power 2. 1 is multiplied 1 is multiplied by 2 raised to the power 0, plus the first 0 is also multiplied by 2 raised to the power 1. Then we have 2 raised to the power 2. So we have 2 multiplied by 0 raised to the power 2, 2 raised to the power 3, and 2 raised to the power 4. The 0, the one with the 0 in front are going to be 0, so we don't need to bother about that. So we come to the right here. We see that 2 raised to the power 4 is 16. 2 raised to the power 3 is 8. 2 raised to the power 2 is 4. Perform multiplied by 0 is 0. So with this, we have 1 multiplied by 16 plus 1 multiplied by 8 plus 0 multiplied by 4 plus 0 multiplied by 1 and 1 multiplied by 1. The one with 0 are going to be 0. So we have 16, 8, 16 plus 8 plus 1, which is 25. That gives us the binary, that gives us the decimal number. The next one is going to convert a binary to hexadecimals. Hexadecimals are in base 16 or not, 60, have 16 bits. So if we have our 8 bits numbers, we will divide the 8-bit binary number into nibble, that is 4. A 4 is known as nibble. So we are going to then we convert each group into its equivalent hexadecimal table. For example, if you have 0, 1, 0, 0, 1, 1, 0, 1, we want to convert this into hexadecimals. We will split it into 2 nibbles. A nibble is where the byte is 4. So we take the first 0100 as one group and 1101 as another group. On the left nibble, we will convert it into decimals. And this decimal, this raised to the power 0, raised to the power 1, raised to the power 2, and raised to the power 3. and the 001 are going to be 0. So raised to the power 3 will give us 4. Raised to the power 1, raised to the power 2 will give us 4. So 2 raised to the power 2 multiplied by 2 raised to the power 2 multiplied by 1 give us 4. So we have 4 there. We come to the right side of it. We have 1 here, we have 1 here. So raised to the power 0, raised to the power 2, raised to the power 1, power 2, and 3. So this one will give us 4. Uh-huh. Yeah. This one will give us 8. Sorry. 8 plus 4, which is 12, plus 1. That will give us 13. 13 in the hexadecimals is 10 from 10, 0 to 9. So from 10, we have 11 is A, B, C, and D. So we have D. 9, 10 is A, 12 is 11 is B, 12 is C, and 13 is D. So we have 4D. So that's why we have the hexadecimal 13 representing D. So we have 4 at the first side and the D at the second side. So converting 0 1 0 0 0 1 1 0 1 to hexadecimals become 4D. The next one is how to add two binary numbers together. And adding two binary numbers which are complement. When we say complement binary numbers, in number system we have positive and sign and unsigned numbers. Positive is sign and negative is unsigned. So we are going to use sign numbers, which means these are positive numbers. We are going positive binary numbers, which we are going to add. So use the representation sign integer like addition. What we do in normal addition is what we are going to do. These are positive number, they are not changed. When they are negative number, we always invert the last number by 1, which we shall see in the next class. So adding example of addition of 1000010010101 and 0100111110 is the same as writing in addition, writing it like in addition in our normal decimal system. So 01010101 plus that is the same as doing addition like this. So we are going to add 0 plus 1 is 0 plus 1 is 1, so we put a 1 down. 0 plus 1 is 1, we put it 1 down. 1 plus 1 is 2. Since it's 2, we just like we are saying that we have 5 plus 5, which is 10. So 2 is 0. Remember 1. We add a 1 to this 0. We add it again. We have 2, another 2, which is 0. Remember 1. We have 1 here. Yeah, we have 1 here. Okay, remember 1. So this will be 0. Then this will be 1. 001. This one 00. This is 0. This is 2. And that is 0 plus 0, which is 0. And this is 1, 2, and this is 0. We add a 1 here. So when we add these binary numbers, this is what you get. What we have to understand is when we have 1 and 0 is 1, but 0 and 1 is 1. When we have 1 and 1 is 2, the answer will be 0. We carry the 1 up to add today, just like we carry forward in our decimal system. So let's recap. Conclusion. Recapping the process is that we emphasize that we have to emphasize the importance of practicing conversion and the binary number arithmetic. In binary arithmetic, it's just like doing the other arithmetic. Um, so these are some questions you can practice. Simple questions and answers. What happens if the decimal number is larger than 222,255? It cannot be fit into a bit. You will have to need to send it to hexadecimals. How does the two complement handle subtraction? Subtraction is done by adding two complement numbers, but we have to add we add one to the right. Okay, then what if there's a carry on a binary number? We add it to. So that is what binary is about. Go read or go watch this video again, and if you don't have any question, if you have any question, please you ask me. Thank you for the class. Any question? 2 minutes question time. If you have any no question, then we'll end here. Thanks.